friends, welcome to my channel Tech Savvy. Today we are going to create a project in Terraform to do the hands-on in Terraform and follow the best practices of Terraform. So here is the agenda for this video is first we will understand what is IAC, that is the infrastructure as a code. Then we'll understand what is Terraform. Then we will understand the project architecture, what we are going to design throughout the project, what will be the expected output after the from starting to end. Then we will do the lab setup. Then I'll walk you through the blog page where I have written everything related with this project, from where you can take the reference of this video as a document part. And then at last we will understand the best practices of Terraform. So let's just move and understand first what is IAC. Okay, so IAC is nothing but it's an infrastructure as a code. It's a way of managing and setting up your infrastructure using code rather than manually configuring individual system. As you can see in this diagram also, we have a files. See, we have a files in which we write a code. What code we write? Which will design the infrastructure. Like for example, if I wanted to create a virtual machine, I can write a code to create a virtual machine and I will run that and it will create a virtual machine in my infrastructure. Next is, what is Terraform? So Terraform is a software tool that help you to manage and set up your infrastructure, such as the computer and server you use for your business and website purpose. So what happened here is, Terraform is like an IAC tool. It's help us to write a code which will design the infrastructure using targeted API. The targeted API could be anything like AWS, Azure, GCP, Alibaba, IBM, or we can also design our on-premises infrastructure also with the help of Terraform. The only thing is we need to use the correct provider to create the infrastructure in Terraform. Now, the architecture of the project, what we are going to design using Terraform code. Everything whatever I am going to use, all the services or all the infrastructure which we are using in this particular project is in AWS. We are going to design the infrastructure in AWS using Terraform. Okay, so this is the architecture, like high level overview I will give you. What we are going to do, we will create first one S3 bucket in which I will upload one object. Okay. Once the object is uploaded, it will invoke the Lambda function which will have a Python code. So that Python code is going to record all the information what is there in the object into this here. It will hold. That Python function will only read the information what is there in the object. Once this task will done, then it will call the API. Once the API gateway will call, it will give the URL to display the content what is written in the object, and it will display. But now that API URL is not enough. I want to redirect it through the caching service, that is a CloudFront. So what I'll do, I'll call my content delivery network like a CloudFront as a cache service for me, and I will create or I will attach this URL API gateway URL with the CloudFront. Once this will done, so we will get the CloudFront URL as a final output, which will have the content what is written in the object we can see over the CloudFront URL. So this will be the expected output. Whatever I am uploading in the S3 bucket, the content which is written in the object file, it has to move throughout the Lambda and API. Then it has to display over the URL or over the browser with the help of CloudFront URL endpoint. Along with this output, I want to perform 3 more tasks. Whatever code I have written, first I wanted to convert that code into the graph format. I want to see the graphical representation of my code, that what all are the dependencies and what all are the how the infrastructure is look like in terms of Terraform. After that, I want to manage my state file as a backend of S3 Bucket and DynamoDB. I will configure that and I will store my backend or my state file into that. After that, once all the work is been done, I have my code readily available with me. Now I want to push my code automatically into the Github repository. So the whole code which I have written here, it has to automatically run and perform the task, and it has to give me the URL as an output, and it has to push all the code into the GitHub repository also. So this will be the architecture of the project which we are going to perform. Okay, so let's just move towards the lab setup. Okay, so for lab setup, what you need to do, first you need to download the Terraform binary. So just go into the Google and type Terraform download. So once you type the Terraform download, you will get the link from the HashiCorp that is having a installed Terraform. So here you will get the various kind of operating system where you can download it. So here as we are going to work on the Windows, so we will download that, the Windows version. Just go and download this AMD 64. So download that. So where you want to store, so let me go and store into the download section only. So save it. Okay, so we have this folder downloaded. So just go and extract it here. Okay, so we have this binary file available. Now what we need to do, we just need to copy this and go to C drive and create one folder here, Terraform, and paste this binary into here. Now just copy this path and go to the environment variable to make this binary available at any place. So just go to environment variable, env, sorry, this one, yeah. Go to this and click on this environment variables here and select this path, edit, create new path. Okay, it's already present here, so just no need to do that, it's already there. If it is not there, just click on new and paste that path, that's it. But as it is already there, so I will delete one and okay, yes, like this. So we are done with the lab setup. Now to create the code and to run the code, we need Visual Studio Code. So easily just go and download the Visual Studio Code from the Google. Visual Studio Code downloads. Download this particular exe file and install it. Once you install it, you will get this particular dashboard. So here what you need to do, go to this extension tab and type HashiCorp. Once you type this, you will get this official plugin for that. So just go and install it. Okay, it's installed. Now go to the terminal and type Terraform version. So you will get the version. It means your Terraform lab is successfully configured. So we are done with our lab setup. Now let's just move towards the documentation. So yeah, see, this is my blog page which we have written for this project. Don't worry, I will paste the link of this blog in the description blog. You can go and take it from there. So this blog is about, it will give you first brief information about the IAC, what is IAC, then it will make you understand about what is Terraform. Once you are done with this, it will give you this particular tab where you will get the code with Terraform, where all the code related with our project is present. Along with that, you can also get this cheat sheet link which will have all the Terraform related commands what all are the major commands and sub command is required for running the Terraform. You will get all the Terraform command in one page. Okay, and here you will get the advantages of Terraform and disadvantages of the Terraform. Just go and click on code with Terraform page, where you will get all the code related with the project which we are going to use. I have already written the code. It is already available in my GitHub repository. You can go and take it from there. But in this today's video, I will just go and walk you through that how you can go and use that code and how you can go and run that code. So just go and click on this code with Terraform tab and you will get this page where we have created a POC on AWS services like IAM, S3, Lambda, API Gateway and CloudFront using Terraform. So the same project architecture which I have explained you earlier, we have written all the code here. So in this page only you will get the link of the GitHub URL. I will also paste this link into the description blog, but I will recommend just go and refer this document because this document is having everything related with this project. So here first what we are going to do, we are going to create one S3 bucket. Then we will create or we will upload the object into that S3 bucket. Then we will create a Lambda function. Then we will create an API gateway. Then we will create a CloudFront. Then we will create a Terraform backend and output blocks along with the graph and git push option. Okay. So all those things we are going to do now and we will perform the practical. Everything is here only in this documentation. Now, before moving towards the writing towards the code, we need one prerequisite, that is you need to create an AWS free tier account. I have already created one video on AWS free tier account, creating a free tier account. I will paste that link also into the description blog. You can go and take it from there. So I already have my AWS free tier account with me. So this is my free tier account where I am going to create one IAM user which will have full administrator permission so that I can use that user into my Terraform code. So just go and create one user, add user, username is Terraform. I need next, cancel. Here I want to generate a auto generated password. Next, let's just attach the policy is administrator access policy. Next, create. Okay, so we have created one user, but okay, let me download this CSV. This is the like console access we have got. Return to the user list, and now just go to the security credentials and generate one access key and secret access key, because I am going to use that into the command line. Understand? Next. No, I don't want to give the tag. Generate and download this CSV and you will get this. Okay. Now, yes, save it. So just open it and keep it with you just for a while. Okay. Now close it. Okay, done. So we have access key and secret access key with us. We have done the lab setup with us. Let's just go and visit the GitHub URL, which is this one, and let's just clone this repository so that I can teach you from where to start and how to start and which code and which block you need to refer for each segment or each part. So just copy this URL from here and just go to the download section and create one folder like tech savvy Terraform demo and enter, and just go and open the terminal here and create and type git clone and the URL and enter. Okay, great. Just close this and you will get this folder. So as you can see, I have complete code in my local system now. Okay, you can go and fork this particular repository also, so it will be in your particular GitHub account also, right? Now what I'll do, I'll go and open that code into the Visual Studio. Okay, yes, so we have the code repository here. Yes, I trust the authority. Yes, now let's just go and again open the Visual Studio code. Okay, this one. Yes, great. Now just go here and create one more folder, and let me create demo tech savvy Terraform. I created this folder and I will use that for showing you the demo. So let me open that folder again, downloads, under this, yes, this one. So whatever demo I'm going to show you, it will be present here, and we already uploaded that code into the GitHub repository. You can take it from there, no problem with that. And the documentation part is already present in my blog page. We have done all the documentation related with the project, so you can go through and visit this blog page where we have created all the documentation related with this project. Okay, now let's just go and start the project. Okay, so as a architecture, the first part is we need to create a S3 bucket. So just go and see the code related with the S3 bucket. So this is the page where we have created the S3 bucket, but before that we need to do some prerequisite. We can't directly go and run the code. We need to create some of the architecture for this project. So what we will do, first we will go and create some of the file like variables.tf, which will hold all the variables. Okay, .tf means like this is a Terraform file. Okay, Terraform.tf vars, where we are going to put all the variables values. Okay, now yes, and yes, we will create one provider.tf, which will hold all the information related with the provider. So as we are going to create everything into the AWS, so let's just go and bring the code for Terraform provider. So just go and type on the Google terraform.io. That is the registry page where you will get all the documentation. Okay, just go to this AWS provider directly. Yes, this one is registry.terraform.io. I was wrongly selected that terraform.io. So here you will get the provider block. So this is the provider block. You can go and click here and you can directly copy this. So just copy this and paste it here. So here we are going to inform my system or the Terraform that I'm going to use AWS provider for throughout this project. So it will go and use the AWS binaries. Okay, so we have pasted all the AWS provider related code here. Now we need to authenticate, right? We need to inform we have Terraform related binary. See what we did. See, we have AWS cloud, right? I have taken down my access key here and the secret key with me from the AWS, where here is we have a AWS account, okay, in the cloud. Now in my local machine, I have downloaded all the Terraform related stuff. Okay, I have selected Terraform provider. Now just to make and establish the connection between them, I need to pass this access key and secret access key here so that he can go to the cloud and create the infrastructure. Simple as that. So now what we are going to do, we are going to configure our credentials here. So we will just simply type AWS configure and enter. So it will prompt me to type the access key and secret access key. Right now one old access key and secret key is present, so it is showing there, but for you there might be a chance it will not show anything. So don't worry, just go and copy this access key and paste it here. and then enter, and then secret key, just copy and paste it here like that. It is taking default region as US East 1. Yes, I want to create my infrastructure into the same region. If you want to go and create in a different region, you can go and type that, enter and enter. So now I have established the connection between my local machine to my AWS account. So whatever code I will write, it will go and create the infrastructure into my account. In which region? In US East 1 region. Okay, so yeah, great. So now first what we are going to do, we are going to create a S3 bucket. So let's go and check whether any S3 bucket is present in my account or not. See, right now I don't have any bucket in my account. See, no buckets. So let's just go and write the code. So simple, just go to this S3 bucket and copy this code. Just go and create one file here like this, AWS S3.tf like this, and paste this code. Now let me explain you what this code is. See, first code is creating a S3 bucket. So what is my bucket name? This is the bucket name and the tag which is optional, but I'm giving that tag. Okay. Then I'm giving the permission, ACL permission, like what is this bucket is private or the public. I'm going to give that permission here. Along with the dependency block, yes, definitely once the bucket has been created, then only assign the permission. Otherwise, no need to run this block. That's why we have given the depends on clause here. Now, if you go and see that there are many variables thing I have used. So why I have used these variables thing is, see, we want to create a code which is generic. I don't want to create a hard-coded code. I can directly pass the bucket name here in the double string, it will take it. But next time when I need to run the code again, I need to change that bucket name at every places. So that's not the best practice of Terraform. Just always try to use the tfvars files and the variables files for this. Okay. Yeah, so let's just go and search those variables also so that we can put them into the tfvars and the variables file. So just go to the tfvars first and see the bucket name and the region here. So just copy both the variables from here and just paste it here. Along with that, just variables, under variables, just copy these two and paste it here. No need to pass the default value also, it will take automatically, that's not an issue. If you want, you can give the description also here, that this is the bucket name, it has to be globally unique, like that. Any description you can give. Okay. Yeah. So let's just see what are the variables I have used. I have used the region and the bucket name. So did I pass the bucket name and the region here? Yes, great. And I have also used the environment here. So did I given the environment? No, I have not given the environment. So it will throw an error. So let's just go and search the environment variable. Where is that? In the code. Yeah, this one. It is there. Maybe I have taken in the variable. Yes, my region. Okay. I have not taken the region here. So just copy the region here like that. So just try to keep all those things line by line, so it will not create a confusion. Like this, copy the environment here, like here. So yeah, so 3 variables we have selected. Now any other? Yes, we have to select this var.acl also. So just go to the variables and copy this ACL variable into the variable tab and the Terraform ACL into this. Yes, here. Okay, so we are done with our first set of code, which will help me to create a S3 bucket. Okay, so the first command for Terraform is you need to initialize the directory. why you need to initialize the directory is, right now this folder is not having any information or any dependency or any API call or any dependencies binary file which will help Terraform to go and create the infrastructure into the AWS account. So first, with the help of Terraform init command, we download those dependencies. Okay, so just simply type Terraform init here and enter. So it will go and initialize the directory and it will download all the related dependencies here. You will see here. Okay, see, it has downloaded all the related dependencies here, and one log file has been created which will hold the version of the AWS. Now move and run the next command, that is Terraform plan. So if you go, you will find all the things here. See, first write the code. Once you have written the code, like everything, see, under AWS S3.tf, you need to write the code related with this. Under variables, you need to type the variables. Then you need to type the TF bars. Then once you are done, right now it is showing that upload also, but you can go and run the initialize directory and plan and apply also. That's not at all the problem. Okay, so just go and run the Terraform plan, which will show you the prototype what it is going to create in my account. Just simple go and type a Terraform plan and enter. Okay, see, so it has generated that plan, that is, it is going to create a bucket which will have these parameters, which will have the ACL enable also. Okay, now it is going to add two things. One, create a bucket and assign the ACL to the bucket. So yes, I'm okay with the prototype, so I will just go and type Terraform apply. Okay, see, so once we run the Terraform apply command, it will again take the confirmation from me that I'm going to create these two resources in your account. Are you okay with that? Yes, so I will type yes, I'm okay with that. See, it will go and create AWS S3 bucket. It is creating. It is giving one error. Okay, so now what is the error? It is saying that access denied. Okay, why I have access denied? Okay, it is saying that I don't have a permission to assign the ACL into that bucket. So let's just see whether the bucket has been created or not. So just go and refresh it. So see, yeah, bucket has been created. Yeah, right. Okay, so as we are getting this error, so let's just troubleshoot that why we are getting this error. So the error is in this block, right? That is, while assigning a ACL, it is throwing an error, that is access denied. So let's just start and troubleshooting this. So just simply go copy this block and go to the Google and paste it here and just go and search that. Okay, so here if you go and see that under down, so it is saying using ACL as an argument is not deprecated. So then what we need to use? We need to use the resource block of this one. But yes, we have also followed the same. We have used this block as a resource block to assign the ACL permission. So let's just go and click here. Now what happened here is, what we are doing, we are creating a bucket, then we are assigning a ACL policy. Now let's just go and see that what changes has been done in the ACL block. So if you go and see here, it is saying you can't directly go and attach ACL. You have to first use this ownership control also, right? But here with private ACL, with public and read ACL, and with grant ACL. So there are three types of ACL it is saying. So why it is happening? Let's just try this way. What we are doing right now, what permission we are giving? We are giving public read and write. Sorry, public read write permission. We are giving that, okay? But it is saying it is having now only three options. See, earlier when we were giving, let me open once again here. Earlier ACL block was having this many types of permissions, right? We can pass it this like that. But now we have only 3 types of permission, that is private, public read and grant. So as we want to give a public permission, so we need to use these 2 blocks, okay, these 2 also before applying that. So just copy this and paste it over here. Okay, now just give some name, meaningful name here. What name we can give? We are giving a ownership control. Under this we need to pass the bucket, so just give the S3 AWS S3 bucket and give the API bucket dot id, right? This, and then see here, I want to make the bucket owner preference, that's completely fine. Now here what we are giving, we are giving access block, so give it name as access block, and here also again change the bucket name dot id, right? So I am just giving this block as public. Now here, see what we have done in these 2 points. Let's just go and see that here under S3 block, under S3 bucket. See this is my bucket, okay, which I have just created. So under this bucket, if you go and see this permission tab here, right now it is on, right? So let's just write on. So we need to off it, and we need to change this ownership permission also to the bucket enforce enable. Right now it is disabled, we need to enable it. So this is what we are doing right now. Also, instead of this depends on bucket, we need to change the dependency towards these 2 ownership which we have changed. So let's just comment it out, this one, and just pass it these 2 block. One is AWS S3 ownership control and the other one is AWS S3 public access one. Okay, yeah, like that. So we can give this 2, and it is saying error. Yeah, I need to pass the comma here like that. Okay, yes, so we have given the 2 dependencies. Now let's just try and run it. See, now we have not got any error, and if you go and refresh this page, so you will be able to see the things. Now here, see, it is public, my public, everything is public. So now the question is why this error is coming and why we need to add these extra 2 blocks. But here the code which I have run, it was also working fine. That's why I have pushed that code into the GitHub bucket. Now the problem here is, see, just go to this log file, okay, terraform.log file. So what Terraform provider version we are using? We are using 4.65 because we have passed the latest version here. And if you go and see my code which I have written earlier, it is having the provider block is this one, any greater than 4, but not exactly this one. See, if you go and see here the log under this, you go and see the version what I am using I am using 4.48. That's the problem. So how to verify that? See, just go to this page here. Above that you see this, the version code 4.66. So in the latest version they have made up some of the changes. That's why they are adding these 2 points here. But as I have written the code with the previous version and I wanted to show you all those stuff what I have created, so just go to the older version here, that is 4.80, and see here I was able to assign a ACL directly, and the ACL types could be anything here. It could be anything, right? So as I want to show you the older code only, so I'll do one thing, I'll switch this provider version to the little bit older version. Okay, so if you will also face this kind of error, so just go and verify once the block, there might be some updation. Just go here like this and save it here, and again do the Terraform init. Let's see what happened. it is showing that it's having a dependency log, but I want to upgrade it to the lower version. So just we need to run the upgrade command. Okay, what it is saying? Okay, so there is one more way to do that. We can delete that dependency log file here, and we can again run the Terraform init command like that. Okay, sorry, that was not required. It was updating and I have not seen that. It was already updated that, but no problem. Again, we have got that. Okay, see. So now if you try and run that code again, okay, so let's just first destroy that. Okay, now let's just try to run Terraform apply again, and let's see what happened with this newly added block, whether it is supporting or not. Let's see that. It is supporting, yes, right? But let's just go and do the Terraform destroy here, and let's remove this block also. Okay, just delete that because it is having already having the dependencies. So just remove that, and under here also, yes, so just delete it. Just 1 second, it is destroying, and delete that. Yes, done. Now let's just try and run the Terraform apply again, and let's see whether it is supporting those blocks. Ideally it has not, but see, it is still supporting that because it is taking the latest thing updated. But I want to show you without that. So let's just comment it out here, and let's see what happened here. Let's just comment these two and uncomment this. Let's see whether my code is working or not. Let me destroy this. Ideally it should not take, but I don't know from where it is taking. I just wanted to get the confirmation from where it is taking. Maybe it is taking from the state backup file. Yes. Okay, so let's just do one thing. Let's just delete the state file also like that, and let me again run the old code with this only. Okay, so let's just run that code and comment it out like that. Let me try it now. This is weird, but okay, it is taking. Then we can't stop to taking it, but let's just see and again comment this and uncomment it and comment these two and save, and let's just destroy also. Now run. Now my code is in older state, the way I have pushed the code in the GitHub, so it's in the same state. So let's see whether it's working fine or not. So yes, Terraform apply. See, this time I guess you will not get that error. Okay, still it is having that error. Okay, it means now it's mandatory to pass those blocks. So no problem, we have troubleshooted that already. So yes, so these are the mandatory blocks now. So just uncomment it, and here also clear the dependencies like this and apply. Okay, great. So we have created S3 bucket successfully. Also the error which we are getting, we have resolved that also. Now next part is, now under this architecture we are successfully created a S3 bucket. Now let's just upload the object also, and we will upload this object with the Terraform code only. Okay, yeah, so let's just go and write the code. So we have already have the code here, so let's just go to this blog and see, this is the code we have for uploading the object. So just copy that and paste it here, and let's review it. But before that, we have one folder that is name is object. Under that we have one sample.txt file which is having some content which we want to upload into the S3 bucket. So just simply go and create one folder name object. Under that, just go and create one sample.txt file the same way we have, and let's just copy the content. Hey folks, okay, welcome to my channel Tech Savvy. Please like, subscribe and comment. Okay, so we have created one sample.txt file which we want to upload inside the S3 bucket. So here we have created this S3 object blog. Under this we are passing the bucket. We can directly pass the bucket name like that, or there is one best way as a best practice. We should not give the bucket name like that. We should refer the resource block. So let's just type the S3 bucket and under that API bucket.id. So it will automatically connect the S3 bucket. Now here var.object key. Yes, now what we are passing under this var.object key, var.object source, we need to pass those things also, right? So we need to go and search those variables under the variables folder, under here variables, and yes, what is that? Object key. What is that? Object key and object source. So let's just go and copy these two variables and paste it over here. Okay, here. So instead of that, we can also directly give this variables like that. So it will be like very short code for us. So save. Okay. Now I want to pass these two variables value into the tf bars file. So just open that. Under this, object key and object source is this one. So just copy that and paste it over here like that. So here object key is nothing but the object name what we have given, that is sample.txt, and object source is like the file location where that file is present. So simple. So here what we have done, we want to upload the object into this bucket. What is the key name of the object is, what is the object name, what is the object path, we need to pass it. And leave that part, that's not important. And the ACL is like at what level we want to upload this object. So object ACL, we need to find this variables also. So object ACL is we want to upload this as a public only. So here just pass it at public. Also along with that, just declare that variable, this one, object ACL. So just go and pass it over here like that. Okay, so done. Now let's see next part. Here let's just remove that part. It's just a anyway, it's just a commented part. So file md5 is just a function. So here what we are doing, we are giving the tag to our object. Okay, and when this object should upload, obviously once the bucket has been created, then only we can upload the object. So we have given the dependency. So just go and save it and do the Terraform fmt command to format the code structure like this, proper spacing. Okay, now let's just go and run the Terraform apply auto, or just run first Terraform plan just to check the prototype. Okay, so it is having some error. Now what it is saying, install.plugin is closer, and yes, it is saying it is having some thing which is not matching, so we need to run that Terraform init once again. Okay, let's just run it, Terraform init. Let's see. Okay, so the problem is maybe I have created this object here out, it has to be outside like this, the wrong place I have created, so just move it outside. Okay, yeah, now it will go and run the Terraform plan. Let's see what content we have right now in our bucket. So go inside the bucket and see, right now we don't have anything here. Okay, so plan is successful. It will go and create one object inside the bucket. Okay, so let's just go and run the Terraform apply -auto approve. Okay, see, so it is successfully uploaded. Just go and refresh here. See, my sample.txt file is now uploaded. Okay, yeah, great. So now next, let me check whether I am able to see this over the browser or not. If I will not be able to see that, then yeah, it is allowing me to download. Yeah, that's great, because it has to be public, right? Then only it will go to the my end CloudFront URL where I wanted to see the content what is present inside this object. So now next part is we need to create a Lambda function which is having a Python code which will be invoked once the object is being uploaded here. Okay, so yeah, so let's go to the code here and go over the Lambda function. First we need to go and create some roles. Okay, don't go and directly create the role. Let me just show you what is the need of role and why we need that. So first just go and create one Python function. So this is my Python function which is taking my bucket. Under that bucket, whatever content is there in the object file, just go and read that and print that content. That's it. I just wanted to perform that task. That's more than enough. So just copy that and create one file. The name should be same, okay? Otherwise it will create the problem. So just cursor is here, lambda api function.py, lambda api function.py, and copy that content here. Okay, and my bucket name is like api1, so I need to update that, otherwise it will throw an error. Okay, let me verify my bucket name again. Yes. Okay, so my Lambda function code has been created. Now just go and see the Lambda function code. So here we have one file called Lambda function. Okay, so just let me just copy the complete code and paste it over here. What is the file name? Yeah, here just create Lambda function.tf. Okay, and copy that. Okay, so let's just see what it is doing. See, the code which I have written here, the Lambda function is having a functionality. We can't go and directly pass our code. We can give our code, we have to give our code in the form of zip. Okay, so what we have done, first with the help of first block, what we are doing, we are taking a source file and we are converting that source file into the zip, and we are storing the output at this location. So we have declared these two variables. Okay, now we need to find the value of these two variables and we need to declare it here. So let's just simply go under this tf vars file and go and find the value, like Lambda function zip location and the source file. So just copy that and paste it over here. Okay, so this is the source file location, like this is the source file and this is the location where they need to save the output. So what they will do, in the current directory they will create one folder called output which will hold this zip, with that zip we are going to use under Lambda function. Okay, so just save it and go and declare these two variables under here, variables, copy that and yeah, and now the second one is source file. So just simply go and type variables like this and here like that, save it. So we have declared these two variables and under Lambda function we are done with the archiving part. Now what we have done here now again is, now let's just move and create one Lambda function. So we are creating one Lambda function, that name is AWS S3 API Lambda function, under which the code which Lambda function need to refer is stored in the zip location. This one, this is the output path. Obviously we can directly go and refer that path here also. And then the function name is the function name what we want to give to my Lambda function name. So okay, so let's just go and find the function name. So this is the function name which I want to give. So just pass it over here and pass this variable as a declaring. So just give the variable declaration here. Yeah, like that. Okay, done. So let's go to the Lambda function again. Let's see what it is saying. We need to attach one role. Okay, what role it is, we need to see that. So let's just go and understand this role, API role ARN. Okay, now what does it do? Here under assume role we need to create, which will be used by Lambda function, which is having a full permission of S3 bucket and the API gateway and the CloudWatch, everything we have. Okay, you will understand the need of these API gateway and the CloudWatch in the later part, but right now as Lambda function and S3 are going to be connect together, so when two services wants to communicate with each other, we need to pass the role just to give the permission that yes, I'm okay to use that other service. Yes, I'm okay that yes, you have a permission. Okay, so what we need to do, we need to create one policy and we need to create one assume role. Okay, so this is the two codes. So what I did is just for the code separation and for the understanding purpose, I created one folder which will hold my all the IAM role thing. Okay, now just go here and create one folder name IAM like this. Under this, just go and create these two files. Okay, let me copy the name so that it will not get confused. So just create one file .json. Okay, another file also let me go and create, which will hold the policy .json. So under assume role, what I'm doing, I'm creating one assume role for Lambda. Lambda is going to use that role. This is the Lambda function. What permission it is going to use, of which service it is going to use it, S3 and API gateway and CloudWatch. So these use you will come to know later, but right now just understand the S3 part. So just copy that and paste it over here. So we have created two roles. So under Lambda function, if you go and see that part, IAM role API role.arn. Now the point is, see, we have passed these two JSON file and we are directly passing the role here. We have not written any of the code block which will create the role for us. So first we need to create a role which will be passed on here. So what we will do, see, there is one more folder or one more file, sorry, which will help me to create the policy and the Lambda role. So just go and copy that code and create one file that is called as lambda role.tf. Okay, so with this what we are doing, we are creating one role which is going to use this policy, that is var.assume role policy. Like, see, I'll show you what it is exactly. See, we are writing one resource block which will help me to create a role. Now what type of role, what role name I wanted to give, which policy it is going to use, we need to pass that. But before that we need to create one policy. Okay, so this is the policy name and the role API like this. So just go and search this Lambda role name here into the TF bars. Okay, yeah, so this is the Lambda role name and the assume role policy name. These are the 2-3 variables. Lambda role name here. Where is my TF bars file? Let me close some of the files which is not required. S3 is not required. Lambda role and function I have created. Yes. So yes, here. Okay, I'm working on the Lambda role now. So let me, yes, Lambda role name. Next variable I have used is assume role policy. So yeah, this one. Okay, what is the path of my assume role policy? So API role, the role name I have given is the API role and the policy name and the assume role policy path. Okay, this one. Under IAM folder, you will find the Lambda assume role policy JSON. Okay, just save it here. Now let's see what next we have. Now this block will help me to create a role. Now this block helped me to create a policy. Under this, we have again given two variables. One is Lambda policy name and the var.policy. So this is the policy name. Just go and paste it over here, and the policy path here. So this is the policy name and the policy path. Along with that, what we have done, we have passed on this policy, which role is going to use this policy. So this is like API role.id. Okay, so we have given all the four variables here. Let's just quickly declare those variables here also, so that we will not face any error like that. So we have updated all the related thing which is required for creating a role and under Lambda function. So we are done with till here. Okay, now handlers, I'm just giving a direct name as a handler. Okay, now under this, see what is the source code. This source code will be present at this location, and the runtime. Okay, let's just see the var.runtime. Now what is the runtime here? Just see, the runtime is nothing but just a language, in which language or which version your code is being written. So my code is in the Python code, so I need to give the runtime. So just give the variable as runtime. Under this, you can give all the variables with the description and the type and the default value. So that's depend on your project to project, but right now as this is the demo, so I am just giving all the variable declaration blank, but you can go and give the complete description also, so no problem with that. So just save it. Yes, done. Now here, and under this environment, we are giving a created by Terraform, and rest other thing I'm just keeping as a commented. So till now what I have done, let me remind you, I have created one data source which will help me. So till now what I have done, I have used one data block which will help me to create a zip of my code. After that, I will use that zip of code into my Lambda function, and also to run my Lambda function, I need one role which will help me to integrate Lambda function with S3. So I have created one role here which is having a policy which will have a full permission of S3 bucket and API gateway and CloudWatch. Right now, as I'm connecting only Lambda with the S3, so you can stick to that the S3 full permission part here, this one. The rest part you will automatically understand in upcoming part. So yeah, let me just go and run that. So but before that, let's just format our code. It is not looking good. We need to align our code. So Terraform format, yes. Okay, also we have used one extra block here that is known as data block. So we don't have dependencies here, right? So if you go and run a Terraform plan directly, it will give you error. It required a Terraform init, right? It is not able to find the dependencies. You have used one block, that related dependencies is not yet present. So just before that, run the Terraform init here. Okay, see, you will get the archive block also here, like that. Now just go and run the Terraform plan again, and let's see whether it is having any error or not. And just go to, in the meantime, to the Lambda, whether you have any function available or not. See, yeah, it is having error. What it is saying, the function called field open output API function system cannot find the specified. Okay, it is having some issue here. Okay, so it is not able to find that function. Okay, let's let's just recheck it here also whether it is having the same thing here or not. Yeah, lambda function, zip code location. Yeah, only problem is it is, see, yeah, here I need to pass on the dependency. What the problem here is, along with the archiving, okay, we have error in the archive block also. Yes, let's see. No, the problem here is the archive is not yet created, and during that part it is creating and running the lambda function. So let me go and create a depends on here, depends on data archive application, like this one. Now let's see whether it is still showing that error or not. Yeah, now it is having error in the archive function. Error in creating an archive function, could not archive the missing file. Okay, it is having the file issue. Maybe I have given some wrong. Yes, this is the problem. See, the name spelling is wrong. So just copy that and rename, and let me do the function spelling is correct. That function spelling was wrong. Save. Now let's see. It is not able to create the archiving. So maybe this was the error earlier also. Yeah, no, that was the different error that is been resolved with the help of depends on clause. Now let's see the Terraform plan again. Okay, still error. What? Okay, again the dot is missing. Now let's see. See, the zip has been created inside the output. See here. Okay, now let's just go and run the Terraform apply now. Apply hyphen auto approve. Okay, see, we don't have any of the function here right now. So under dashboard, you go and see. Okay, see, my code is run successfully. Now just go and refresh the browser here and see whether we have got one lambda function. Yes, we have got one lambda function here. Under that lambda function, we have given one S3 as a package. So no, not S3. See, this is my code. Now done. So let's go and move further. Till here we have created a role, we have created a lambda function, we have passed on the Python related code, everything is done. Now let's see what other code is saying. So this code is saying adding S3 bucket as trigger to my lambda function and giving the permission. So what I want this lambda function to be triggered from the S3. So just go and simply create a AWS S3 bucket notification. So this is the block which will help to trigger my lambda function. So see what it is doing. This is my bucket name. With this bucket name, I want to call my lambda function. Now what is my lambda function? This is my lambda function. I will pass it as a ARN of the lambda function, at which event I wanted to trigger. Anything happened with the object created, object removed, object restored, anything. Okay. Along with that, obviously we need to pass the lambda allow function here. See, this is one dependency. Now what does it dependency is this? This will help me to pass the lambda invocation permission. Okay. Along with that, the CloudWatch log. I want to log my functions record, what is happening over my lambda function. That's the reason I have given the full permission of CloudWatch here. API gateway part you will understand soon, but see, the reason behind giving the CloudWatch full permission is here. I want to record my CloudWatch log also here. So these three block is nothing but what it is doing. It is giving lambda function a permission to invoke. When to invoke? whenever the object has been uploaded into the S3 bucket. That's it. Along with that, we want my CloudWatch should record the Lambda function logs. Okay, so let's just see what all are the variables we have declared here so that we can go and declare and create it. So in this block we have not used any variable, so that's completely fine. Here, is there any variable we have used? No, nothing. No variable is being used. Here we have used the function name as a variable, so let's just go and search the variable here with the function name. So what is the function name we have here? This one. Yes. Okay, we already declared, I guess, that function name. Yeah, we already declared that, so we can directly go and use it. It's nothing but it is passing the Lambda function name. That's it, this one. Okay, so no need to declare anything, just simply go and save it and directly run the Terraform plan first. Let's see whether it is having any error or not. Okay, no error. So let's just go and run the Terraform apply. And let's see here right now you are not able to see any trigger, right? Nothing is invoking my Lambda function. You will soon see the changes here. See, the code is run successfully. Just go and refresh this page once again. See, so what is happening here? The trigger for my Lambda function is S3 bucket, and this is my invocation detail which I have passed on when to invoke. See here, allow S3 invoke my Lambda function, when to invoke, when the ARN, what is the reason, like here, see, S3 bucket. See, everything is passed here. The event is object created, object removed, object restored. Everything is present here related with the trigger. So what we have done till now? So we have successfully created our S3 bucket, we have successfully uploaded our object, we have successfully created Lambda function, we have invoked also along with the Python code. So we are done with this much. Okay. Okay. So now next part is API gateway. So for API gateway we have these two files. One is which is helping me to create an API gateway. Other one is the API gateway integration role which will be required for accessing the other services. Like definitely whenever the object has been uploaded into the S3 bucket, it has to invoke the Lambda function, and once the Lambda function is being invoked, automatically it has to call the API gateway to display the content of the object over the browser, right? So just go and see. Along with that, we need to create these two JSON files. Okay, rest all the things are normal. So let's go and first create the role. Okay, so let me go and create the role. So copy this file and here go and create one more file which will help me to create a API gateway role. So this is the code, same code just like we have created in the Lambda. First we will create one role, along with that we will create one policy. Okay, and we will attach that role with the policy. Okay, save, and along with that we will create two JSON policies here. So one is assume role and the other one is the policy. Just copy that and here go and create one file like this, save JSON, and the second one is the policy .json. Okay, now just copy that policy from here and paste it over here, save it, and the assume role. See, this role is going to be used by API gateway. Yeah, that's what I forgot to explain you. So role is being used by API gateway. What policy? To get the full permission of S3 bucket, Lambda and API gateway, the complete access. Okay, yeah, so we have created two JSON format. Now let's just go and understand this role part. Here what is happening, this is my role name which is going to use this assume role policy JSON format to create a role. After that we will go and create our policy which is going to use this policy JSON which is present here, and it will attach with the role. So let's just again find these 4 variables which we have just now used it. Just delete that like that. Yeah. Okay. Lambda function creation is done, so we will close that, all the dependent file related with the Lambda. So yes, go to the variables again. Now see, API role name. So earlier we have created a role with the name of Lambda role. Now as this is going to be used by API Gateway, so we have given a API role name. So just go and copy the API role name. Where is that? Yeah, this one. These are the 4 things which we are going to use. Just go and copy that directly. See, API role name, API policy name, API assume role, and API policy name. See, which is having 2 policy name and the role name and the path. See, so just go and declare these variables quickly. Variable. See, okay. So let's just go and run the Terraform plan here, so that it will go and create my role. So it is not having any error. It means our role code is correct. Now let's just go and understand the API gateway.tf. See, this is little bit big code. Okay, so just go and create one more file here, which name I will give the same as here. So just copy that and paste it over here like this .tf. Okay, yeah, great. Yes. So we are going to create an API gateway. Now see, this is my first block. Let's just copy the code block by block. See, this is the block which will help me to create a API gateway. Okay, so I'm going to create and use the REST API, and here we have a 3 variables. Okay, so let's just go and use that. API description and endpoint. So just go here and copy that. API gateway and endpoint. API name and endpoint. These 3. And paste it here. Like that. Okay. And just quickly go and declare that. So variable like this and okay, done. Now let's just run the code and let's just create a API gateway. So here just go and search the API gateway, and yeah, same thing you will follow here. Right now for first block we have given the complete code also, but from the next section you will get and see the resource block name, which resource block you need to refer, right? This AWS IAM role, AWS Lambda function, like for API gateway, let me show that. AWS IAM role, AWS policy, API gateway role, like this. See, so these are the block name. See this one. See, these are the block name which you need to refer under this API gateway REST API. See this one. Okay, where you will get this code which TF file you need to refer. It is already having this hyperlink, so you can go and directly click on that, so you can go and use it. So yeah, plan is run successfully. Let's just run the Terraform apply. Okay, see, 3 resources has been successfully created. What all are those resources? API role, API policy, and the API gateway. So if you go and just quickly refresh this page, so see, you will get the REST API here. There are multiple type of APIs we can go and create, like HTTP API, WebSocket API, REST API, and the REST API private. So we have created a REST API right now, which will be work well with the Lambda and HTTP and AWS services. Okay, so yes, go and see. So we have created one API. Right now this API is not having anything. See, no method is available. So let's just go and work on that part. Okay, So go to the code here and go to the API gateway. Okay, so creating our resources for API gateway. Okay, now we need to create the resource first. What is the resource? See here under action, you need to create a resource, then only you will create the method inside that. So we are going to create a resource and then we're going to create a method. Under that method we are going to create first a get method, and we also need to create a post method. Like so many things we need to create. So let's just understand one by one. So let's just go and create a resource first. So here copy the code and paste it here. Okay, so yes, first REST API, we have the parent ID is my REST API blocks ID. Obviously whatever code we are going to create, we need to always attach it with this, so that the methods and the resources and everything should be created inside this parent resource group. So you can see everything is being attached here. Okay, like this. Now we need to give the path. Now what is the path here? So let's just see what we have in this variable path part. Okay, let's see where is that path part. Yeah, this one. So it is having a REST API stage. So just simply go and copy and paste it over here and declare that also. Like that. And see other code. Yes, so this one is done. What we are doing, we are giving a REST API root resource ID and the ID to connect it. Now next is the same here. We need to pass on the HTTP method and the method authentication. We have created a resource, but which method we are going to call it, we need to pass it here. So method authentication and HTTP method variable we need to search. Okay, HTTP method, we are giving a get method. Okay, and the next one is method authentication. So what is that? Yeah, this one, none. We are not authorizing anything here, so none. Save. So we need to declare that. Okay, so let's just go and run the Terraform plan again. Okay, so let's just go and run Terraform apply auto approve. So let's see whether the resource and the method has been created or not. So just wait for the apply to complete. Okay, so go and refresh this page. See, the resource has been created and the method is also been created. Now I want to attach this method with integration of Lambda function. I want to integrate this API gateway with the Lambda function. So we need to work on it now. We need to write the code. So just go here and see that part. Yeah, this one. Integrate API gateway with the Lambda function, right? We have created a resource, we have created a method. Now I want to get the data for this API gateway. From where? From the Lambda function. So we need to write this block. So just copy that and paste it over here. And let's see the next block also. Yeah, I'll share this part in later. Let's just first integrate that here. See what integration? REST API ID. Obviously we have created this REST API ID, so we need to pass that. We need to pass the resource group ID. So this is the resource group ID, we have passed it on that. We have to give the HTTP method here. This one, this is the get method. I need to attach with this. What, see, all the block what we are getting here, it will automatically pass on that here. See, now here, see, integration method, integration type, and the credentials. Now what credential? API gateway role, which will help API gateway to communicate with Lambda function. So we just recently created a role with this code here, this one, right? This is the role we have created. So we have used it here because we want to make the communication between the API gateway and the Lambda function, and it is having a permission of API gateway and Lambda function full. And why S3? Obviously, what are the data we are getting from the S3, it is going to display over the API gateway. So yes, So let's just go and create these two variables, and see, this is the URI of my Lambda function to integrate. Simple as that. Now let's just go and call integration method and the integration type. So these two variables, let's just go and search is integration method and integration type. Yes, the post method and the AWS is the integration type. Save and copy. Let me format also. Yes. So we have written a code block which will help API gateway to integrate with the Lambda function. So just go and run the Terraform plan once again. Yeah. Terraform apply. Yes. Okay, done. So just go and refresh this page and see what is being done, whether it is integrated or not. See, now my Lambda function is being integrated with the API gateway. So we have these four methods, right? Method request, method response, integration response. So we need to update these things also, like when to integrate this Lambda function. Okay, so let's just go and see the code related with that here. So method response, integration response, we need to update these things. So just go and copy these. So let's just first copy that, and yep, let's just copy another block also, that is the integration response, and let's see these two later. Now see, method response, I want 200 response from the Lambda function when these two integrated. So yeah, everything is interconnected, like API gateway, REST API, resource ID, method ID, all are same. All we already created above, so we directly just call it. We have given the reference of those resource block to use it. Now we have used one status code variable here, so we need to declare that. Okay, so just go here and copy the status code. Yes, status code 200. So just copy here and paste it here. Okay, and declare that also. Okay, save. Let's see other one, integration part. Integration, again we have given the reference of all the blocks here. Now let's just go see one by one extra block addition has been going on. Earlier it was 3 here, and here now the status code part, we will get the status code here. Now the next is the response template. We wanted to get the response template in the XML format, that's fine, and we want to run this particular block when the integration REST API part 1 will done. See, if that integration will be done, then only go and create this integration response. If the Lambda integration is not been done with the API, then no need to generate or create the integration response. That's why we have given the depends on clause here. Okay, so just go and run the Terraform plan once again. Let's see whether we have any error or not. Okay, so let's just go and run Terraform apply. Let me run with the auto approve clause so that it will go and directly create. Okay, the spelling is wrong. Auto. Okay, so 2 resources has been created. One method response, method response, and the integration response. So just go and refresh this page again. Let's see. So yes, see, integration response has been created and the method response has been created for the 200. Okay, done. So when the request is being go to Lambda function, it has to give the 200 response. So done. Now let's see the rest of the code here. These are the 2 block is been left out. Now we have created a API. Okay, API gateway and everything, integration response, everything has been created. Now we want to deploy that API. So this is the code for API deployment and adding permission for Lambda function to trigger a API gateway. Obviously till now we have done everything, but we have not given the permission to invoke. So this is that block, the same way which we have given here in the Lambda function when to invoke it, right? That part is already been added here. If you go to the S3 here, see which place the invocation part has been added. Okay, I'm sorry, it's in the Lambda function type. So here, if you go and click here, you will see this invocation part here, right? The same way we wanted to give the permission to Lambda function and API gateway. So here it depends on the integration part. Obviously if the integration is not been done, then no need to deploy the app, and we will pass the ID, that REST API ID. So it's just first go and create the REST API, and the integration has been done, then only go and deploy the application. So what stage we want to give? So let's just go and search the stage name in the variable. So we have a stage name variable. Which place? Here I will find here. Yeah, REST API stage. I'm just passing the name as stage as REST API stage. Save. Just copy that and declare. Okay, done. So this part is done. Let's just go and see the invocation permission. So it's just statement ID. You can give any invoke when Lambda function, and we need to pass the Lambda function ARN, and the principal we need to go and search. So what is the principal? So just go and find that. Sorry, API gateway principal. Yeah, this one. What is the API gateway? Amazon.aws.com. Okay, so yeah, just go and pass it here and declare that. Save. Okay, now just go and run the Terraform plan again. Yeah, one more point. Yeah, this path, that's what I forgot to explain you. Source ARN. See, API gateway need a ARN. See here, this ARN is been created like this one, this part. So I already variabilized everything here, so we need to go and see that. So let me wrap text here, what wrap like this. Okay, so my region, we already declared that variable here, region part. Let's just see the error, how many errors we have. What it is saying, variable account ID is not yet declared. So just simply go and see and declare that account ID here. What is the account ID? Yeah, this one. So let's see what we have in the account ID here, this one. Okay, what exactly that account ID is, like maybe I guess this is my account ID, right? I need to pass it there. So yeah, you are nothing but AWS account ID, you need to pass it over here. Just go and copy and paste it over here. Save and save. Okay, let's see, still having any error? Yes. So just go to the API gateway. Okay, stages, authorization. See, under this REST API, under this resource, you will get this is the ARN which we have just now generated. Okay, this ARN has to be correct. So this ARN itself is having some format. So this format I have passed on here. This is the combination of some of the parameters. So just simply like this. Some is having a API REST API gateway ID, then the method, then the REST API response resource path, all those stuff you will see here. Okay, now next is, let's see what is there. Okay, done. So let's just go to the APIs. See, my API has been created. Now let me see whether it is working fine or not. Okay, yeah. So this is the page where we can test it. See, so we have queried, so the content which we have uploaded into my object, it is able to display here, right? So we are able to call the API gateway and API response. So it is invoking my Lambda function here. See, it is taking this key and we are getting the 200 response from the body. It is giving this. See, now this is not the correct way to test it or to display that, right? So let's just go and do one thing. Let's just get the invoke URL here. Okay, so how to get that invoke URL? We need to check that part. See, somewhere here, yeah, this one, I guess. This is the invocation URL. See, so till now, whatever we have done, we are just only going and creating the resources, right? We are not getting any output from the Terraform, so that we can go and see whether we are going to correct or not. Like every time we are going to the AWS console and we are searching for the services. I don't want that. I want some of the response from AWS also. AWS should also give me some response at least. Okay, so what we will do, let's just go and create some output block. So we have a lot many output block I have mentioned there. One is invoke URL, one is base URL, right? So let me close this, and then under invoke URL, it's nothing but like a API gateway URL, base URL, also like a API gateway URL, bucket name, Lambda ARN, API gateway parent ID, object ID. Though it is not that much important, but the main important part is this base URL and invoke URL, because we wanted to see the final output, what it is having. So let's see that. Let's just go and again create a output.tf. okay, and just paste it. Right now I just need only 2 outputs, so just go and directly apply that. No need to run the plan, that's fine. Let's see what output we will receive. Great. See, we have got 2 output, that is invoke URL and base URL. So just go and copy that URL, copy, and let's see what response we are getting here. Enter. See, so this is my invoke URL which is having this output. What content I have uploaded here in my object, this one. Okay, now I am not able to remember that part which will give me the invoke URL somewhere here only. I don't remember that part right now. Stages, under that some, yeah, this one. That's what I was searching since long. Yeah, see, under this REST API you will get this stages and you will get this invoke URL. So this will be the URL. That's this URL only we have asked Terraform to return as a output. Okay, so till now what we have done, we have created S3 bucket, we have uploaded the object, we have invoked the Lambda function, we have now created REST API which is having an invoke URL. So whatever content which we have present in the object, we are now able to get through the API gateway. Now let's just understand this part. Okay, so let's just go and quickly create a CloudFront. So for the CloudFront we have this much, this code. Okay, so yeah, let me just go and copy that code for the CloudFront. Let me remove that part as of now. Just delete that because that's the next part related with the graph. I'll tell you that part. Okay, just save it. So yes, I have written a one blog that is related with the CloudFront distribution, which will help me to create a CloudFront distribution. So under that, I will give my domain as the REST API domain. So if you go and see here, let me show you the CloudFront. See, under this CloudFront, create a CloudFront distribution. Here, see, you can go and choose your distribution. So here it is giving me the option to choose my REST API. The same thing, origin domain I wanted to pass. So I have given the origin domain with this part. Okay, which will help to pass the domain. Okay, now origin path is nothing but the path and the stage. So what path and stage it is? This one here. Okay, just 1 second. Where is that API gateway? So yes, this is the path and this is the stage, this one. Okay, this one. This we are passing over here. Origin ID, API, leave that part. These are some of the like a default thing which has been related with the CloudFront distribution. So like, see, default cache behavior when we can call this CloudFront, like what all are the allowed methods. So it's like get, post, delete. I have given all the methods, so you can go and filter out according to yourself. And rest like forward value is like accept, refer, authorized, any content type. And the viewer protocol is like I wanted to use that viewer protocol as a HTTPS only. So if you go and see here, so these are all are the options we are having here. See, the allowed method, viewer protocol, all those stuff we are passing the same thing from the code only. Okay, viewer certification, yes, I wanted to be my URL to be certified, right? I want that HTTPS lock here. Okay, geo restriction, no, I don't want to give the any geo restriction. Delete or retention or delete, it's like you wanted to only delete your CloudFront distribution, like for example you want to only disable it or you want to permanently delete it. Yes, so as of now I wanted to delete it permanently. So this is the code. So let's just go and run that, whether is there any variable. So it will give me that error. So Terraform plan, like that. So yes, no error. And then Terraform apply hyphen auto approve. So it takes 3-4 minutes to create a CloudFront distribution. So in the meantime it is creating, let's just create one output block for the CloudFront URL so that we can get it. Okay, so where is my output block? Yeah, this one. So this is like CloudFront domain, which will be my final output, which I am expecting. So let's just save it. Yeah, this time it will not return that output, but we'll run it again to get that output. Okay, so yeah, we have created one resource, that is CloudFront distribution. So just simply go to this place and see. So we have CloudFront distribution and this is the domain name. So just copy that and paste it over here and enter. So see, so the content which I have uploaded in the object is now I am able to fetch in the CloudFront distribution, and that is also the HTTP secured connection. Okay. So here at initial step, I explained whatever content I am going to upload in the object, it has to display over my CloudFront URL. So we are able to achieve this part till now. Now the only thing is, like, major part has been done. Now we need to finalize our code, like we need to create a graph, we need to create a state file management thing, we need to push final code into the Github repository, and then we are good to go with our project. So let's do that. But before that, let me run this code once again so that we can get the CloudFront URL as an output also. So let's see, it will give that quickly. See, that's the CloudFront URL, the same URL which we have used here. Okay, so let's just go and create a Terraform graph. Like what we are going to do in the Terraform graph is, whatever we have created till now using Terraform code, we just want a graphical representation of our code. So we will go and convert our code into the graph format. So let's just do that. So here, if you go and see that there are so many things are available related with the graph. One is graph.sh, graph.svg and graph.dot. So we will only go and create one file that is called as graph.sh. Okay, so just copy that content and create one more file which will perform all the tasks for us, graph.sh. Okay, under this what we are doing, we are running the command terraform graph, and we will convert whatever code we have present right now into the graph.dot format. So it will go and generate this file which will have all the code related dependencies in the dot format. Once we will have the dot format, we will convert that into the SVG format so that we will be able to see the graphical representation. Now, first of all, this is the shell script, shell file. Okay, like we will do this here with the help of shell scripting. So to run that, we need to run the provisioners. So the last resource block, what was the last resource block? It's a CloudFront. Okay, we have recently written the code of CloudFront, so this will be the last one which will run at the end of our code. Now here we want to perform, once this code is been run, we want to convert the whole thing into the graph also. So what we will do, we will write the provisioner block here, that is a local exec provisioner, which will help me to generate the graph. So we will write the provisioner block here under this resource block, and what we are doing, we are running the command, that is the sh command. That's the file we want to execute. But the problem here is, this is PowerShell and this is the shell script. They both are not compatible, right? So it will throw an error. We won't be able to run it, right? So to run that, we need to make some compatibility. So what we will do now, we will install one more thing in our laptop, that is WSL, okay, which will help us to run the command of like Linux or Ubuntu of any of the operating systems command in our Windows PC. There is one more another way is we can take this whole code into any of the Ubuntu machine or the Linux machine and we can run it there, but that's not the like a good way, right? As we have created the whole project here, so we should resolve the dependencies here only. So let's just go and install the WSL here. So just go to the Microsoft Store, go and search for the WSL. So you will get all the Ubuntu related version here, but we will go and run that with 20 version. So here just go and install it. So it will take some time. Okay, so it has been installed now. Now just go and open it. So once we will open, it will take some time in configuration. So just wait. Press any key to continue. Now again open it. Let's see. Okay, maybe it is not taking. So what we need to do, sometimes it's create a problem. Okay, so if you go here, WSL run command, run as administrator, and then yes. Okay, so sometimes it create a problem. So to resolve this problem, you need to reboot your system. So I'll be right back once I'll reboot my system, and again I'll start this video. Okay. Okay. So we have restarted our system. So let's see once again, WSL run the command. Okay, see, yeah, it's not working. Then just go to the Microsoft Store again, open it. Okay, now just go and type WSL again and open. Click open and see here. Okay, installation tips is having search, turn Windows feature on or off in the Windows search button. Okay, we need to do that part. Okay, okay, and just go here and Windows search bar and ensure that Windows subsystem for Linux is turned on. So we need to go and search that Windows search. Yes, it's turned off. That's the reason maybe. Yeah, okay, click here. Ideally you have to do it earlier, but I have done it in the later part. That's why again now it is asking me to restart my system. So again I need to restart it. So restart now. Okay, so we have restarted our system. So now let's just go and see the WSL part again. So let me just go and try to run this command prompt again, but maybe it will not run again. Yes, so I need to again go to the Microsoft Store only. So what you need to do is first you need to turn on that Windows subsystem for Linux, then go and install this Ubuntu and then restart your PC and then start working on that. Okay, so I missed that part, but yes. Okay, now just go here again and click on open and let's see what happened again now. Yes, so now it is taking. WSL to require an update to its kernel component. For more information, please visit to this. Please any key to continue. Okay, now So to launch, use Ubuntu 2004 on the command line prompt or the Windows terminal, or click on Ubuntu 2.2 LTS tile at start menu. Okay, let's just go and see. Yes, it's a recently added one, so just open it. Okay, so yeah, it is again showing some error, so let's just go and read that error here. So ideally it has to ask this username and password from me, but it is not asking. Maybe. Okay. Okay, so let me first recheck whether my Windows subsystem is turned on or not. Okay, so just go here and open it again, and yes, it's on now. Now the second part is it is not giving properly. Okay, let me try it with the run as administrator. Yes, okay, great. Okay, it is showing that some kernel updates is required. So what we can do, we can do one thing. We can go to the control panel and just remove that, and let's just install it again. Okay, so yeah, let's just go and search it again. Here, click open. Okay, yeah, so now again let's just reinstall it. Open. Let me close that and click up again, open. Okay, it is giving some dependency error, so download a latest package for this machine is this. Okay, maybe we need to download this Linux kernel. Okay, MSI file, yep. Okay, okay, so what I did is like it's creating some problem via Microsoft Store. So what I did is I downloaded this kernel MSI file, and let's see and install it. So here I downloaded that, and no, I don't want to cancel it, I want to install it. So let's see. Okay, completed. So long, so early. Okay, maybe, yep, now it's been installed. So overall what you need to do, you need to install, first you need to enable this option. Once you are done with enabling this option, then you need to download your Ubuntu from Microsoft Store. Once you are done with that, if still it is showing that error to you the way it is showing for me, like this error, then what you need to do, just go to that link which it was showing here, and over that link just download the kernel. Okay, see here, this fourth step is downloading the kernel and install it into your system. So you will get this option like this. So it will ask you now to create a username and the password. So now I will create a username and the password. So yes, now we are able to install Ubuntu subsystem or the Linux subsystem in our machine. So here we can run all the Linux related command using Windows. So just go and restart the Visual Studio Code now. And here, okay, so this one the actual code. Now let me open the other window and open my code blog where I was writing the code for you. File, open folder, and downloads, yes, here, and this one, and just go to the terminal. Okay, you already in terminal. Under this you will get this option, see, Ubuntu 20. So here now, so first just go and update your system. So how to update that? Sudo apt update -y. Now it will prompt me for the password. So yes, okay. So now if you go and see the Terraform version here first, see it will say you don't have anything, any command related with the Terraform. So now let me tell you the thing here. See, this is the PowerShell which is in Windows, and the WSL is like a Windows subsystem in Linux. So you need to again install Terraform here, right? Earlier what you have done, you have downloaded the binary for the Windows and you have set the environment variable. Then only you are able to run your Terraform commands. So now we want to run everything into the Ubuntu machines. So what we need to do, we need to install it. So how to install the Terraform into Ubuntu? Just go and copy that and type Terraform download here. And see, under Ubuntu or the Linux machine, under Ubuntu variant, so these are the commands. So just copy these commands one by one and paste it. Okay, so paste first command, enter. Okay, done. The second command, and done. And the third command, enter. Okay, so now again do the Terraform version. So yes, now we are done with the installation of Terraform version. Now I want to run this command, okay, like this file, that graph.sh. So as I have created this file and I have created the local provisioner also here, where is that, under CloudFront here. So I want to execute this. So let me try first and executing it with, let's just first do the Terraform fmt, so it will format. Now let's just go and run the Terraform plan. Let's see whether it is picking my local provisioner changes or not. Okay, so it is saying that there is an issue. What was that? Okay, so the provider plugins are still not here, so I need to again run the Terraform init. Yes, obviously, because I'm running it into the WSL, so I need to again provide the binary detail of AWS provider. So Terraform init. Okay, so it is again picking up all the dependencies. I hope you are getting the point that why we have done this WSL setup here, because it is required. This graph.sh file we can't run in the PowerShell directly, right? So we need to write, otherwise we need to write the PowerShell script like ps1 format. So that's completely different syntax and all those stuff we need to write. But I wanted to show you into the shell command, and I also want you to learn that how you can invoke that Windows subsystem for Linux into your Windows machine. Okay, so Terraform init is done. Now let's just go and run the Terraform plan again. Let's see whether it is picking the code changes or not. Might be it will not pick. Okay, so it is saying some error. Yup. Now again, it is not able to pick the credential, like in which account he has to run the Terraform command. So yeah, obviously the secret access key and the access key which we have passed on into the PowerShell, we need to pass it again, like we need to configure AWS configure again. So we have our access key and secret key available with us, so we will pass that again. See here. Okay, so Terraform access key and secret access key, yeah, this one. Okay, so yep, here. So just go here and type AWS configure. Okay, so now we need to install the AWS CLI. Yeah, lot many dependencies. Yes. But once you are done with this all the lab setup, it's very easy to run or to use WSL in the Windows. It's very easy to run all the Linux command in the Visual Studio and all your Windows setup. Okay, so now let's just do the AWS configure again, and yes, it will prompt me for access key. So let's just pass the access key, paste, enter, secret access key, paste, enter, and yes, US East 1, enter. Yep. Now let's just run the Terraform plan again. Okay, so it is saying that I have done some changes. Okay, it is not taking my provisioners changes. So what I will do, I will first destroy the infrastructure from PowerShell. Okay, Terraform destroy, auto approve. Okay, enter. Because this provisioner block which I have written inside the CloudFront block, right? And it's already been run once. Already it's run, so it's not picking that changes. So I have destroyed everything. Now let's just go to WSL. Now go and run the Terraform apply -auto approve. So just watch it here. Okay, this time it has to pick this this time it has to pick this provisioner local exec block, and it will generate the dot file and the svc file. But yeah, maybe it will give one more error. Yes, that's related with the graph. To run this command, it required one more installation which we have not yet done. Okay, see, now it has started running this local exec provisioner. See, it is giving the error, right, that it is not able to find this dot command. So to run this command, we need to install one package, that is GraphViz. So install using sudo apt install GraphViz -y. So with this package, you will be able to run this dot command, which will help us to convert the dot file into the SVG. Okay, so installation has been done. Now let's see and run again. if it will pick the changes this time. Otherwise we need to destroy and we need to again run it. Okay, it will pick the changes because it is destroying and it is again creating. So again it will take 3-4 minutes. Okay, see, now it started. Yes, now my graph command has been run, and if you go and see, it has created this graph.file and it has created this graph.svg file. Now to view the graphs, just go to this folder. Inside that folder, see, this is the graph. So just go and open and just go and select the open with Chrome. So just go and just once, yep, see. So this is the graph of my project. Like I have a root, under that I have created like invoke URL, API gateway, S3 bucket, like what all are my objects, what all are the variables I have created. So see, this is the graphical representation of my whole code. var.path, like this, what are the variable I have used, where I have used, in which block I have used, everything is here now. Okay, so yeah. Okay, so now what we have done this part also, right? We have created all this stuff and done. Now 2 part is left. Now this is like a security part. Yes, obviously the state file has to be managed properly. As the best practice, the state file has to be managed. It should not be open, right? Because see, if you see the state file, it is having all your infrastructure related information. Right now we are not using any ID or password here, like a database password or something, any critical information. But most of the time when we use or we create an infrastructure using Terraform, we create a database also. So under that database we will have the ID password. So the state file will not encrypt that ID password. It will be directly apply or applicable here. So anyone can go and hack your system, right, using this state file. So securing this state file is very important. So what we will do, we will secure the state file into S3 bucket, because S3 bucket is having state locking facility available. Now what is state locking facility? State locking is nothing but when you are performing any changes in your infrastructure, because of state locking facility, no one can perform the task during the same time. Once you are done with your changes, then only other person will work on that infrastructure changes. Now how does it happen? How does it work? We will see that. See, let's just go and create the resources which will hold the TF state file. Okay, so that is, we have one resources called backend resources. Yes, this one. So just go and create one file which is backend resources, okay, which will create the backend resources. Here just go and create one file that is called backend resources.tf. okay, see here what you are doing, you are creating one S3 bucket, you are applying the state lock, sorry, ACL over this bucket, that's a private, and you are creating a DynamoDB table which will help you to apply the state locking facility. Okay, there are many backend facilities are available. You can use the Terraform Cloud, you can use the Azure storage, you can use the GCP storage, you can use the GitHub, Bitbucket, anything. But the problem with the GitHub and Bitbucket is they are not providing a state locking facility. That's why it is not recommended to use the GitHub and GitLab as a Terraform backend where you can go and store your state file. So now let's just go and pass on these variables. So let's just go and see and search the state bucket name. Yeah, this one. So just give it here and declare this variable also here, same way. Okay, done. Now let's see whether we have used any other variable or not. Yeah, environment we already declared and it's not required any variable. Okay, here no variable. So let's just go and run the Terraform plan. Let's see. See, while running, see, are you able to see this state log? So this is the state log. Like this state right now is logged with this state, is log ID. So no one at the same time can perform the task. Who has logged this? This is the concerned user who has logged that. Okay, so you can't perform that. See, if you go and open that tf state file, it is opening right now, but when you will apply that changes, no, you will not be able to open that state file also. I'll show that part also once we will click on the apply. See, it is going to create a 3 resources. One is bucket and apply the ACL over that and the DynamoDB table. So just go and create a Terraform apply to create these resources. See, now if you go and try to open the state file, okay, just one second, I want to show you that log. And yes, okay, it is allowing me, but see, it is logged. So it is creating my backend resources. Okay, so yep, the same problem related with the ACL. So again we need to done the same thing what we have done while creating a S3 bucket initially. So we need to pass on these 2-3 things. Okay, so just pass it and copy it, and here under backend resource also you can pass it here like that. So just change the resource block name, access block 1 and ACL 1, and here just change the bucket name as state file bucket dot id, and here also state file bucket dot id. Okay, yes. So and under this you need to give the dependencies. So here okay, I have copied the wrong code. I need to copy this block. Just copy, like this, and just remove this part. Okay, that's not required. Yep. Now, so ownership control, yes, it's 1, and here just go and change the state file dot id, and the public access part 1 is correct now. And let me give the depends on clause also. So depends on what? AWS S3 bucket S3 bucket ownership, and which one? Yep, 1. And yeah, I need to pass it on comma, and I want to give AWS S3 bucket public access block 1. Yes, so these two will be the dependency part, and save it, and let me do the Terraform FMP. Okay, so yes, and here just keep the space properly. Yes, now done. So yeah, now let's try and run it again. Okay, so see, now we have successfully created our resources. Okay, so see, in the S3 console you will see we have created one bucket called state file bucket, and just go to the DynamoDB also. It will show you the DynamoDB table also which we have created. So now I just wanted to show you the state locking facility. So just go and write the one more point. Now we have created the backend resources. Now I need to configure the backend so that the state file which is present here, it has to move to the S3 bucket which we have created. So for that we need to write the Terraform blog once again, one Terraform blog, that is the Terraform blog which we need to write, which will help us to migrate the state file into this bucket, and the key will be this, and the region and the which table it has to follow for the state logging is this one, state logging DynamoDB table. So just copy this Terraform blog from here and create one more file called terraform.tf which will hold the backend resources. So just copy it and yep, done. So now just go and create a Terraform init. Okay, if you go and run the Terraform plan, it will give the error. It is saying that you have created or you have configured the backend, so you have to first run the Terraform init to migrate your state file from here to S3 bucket. So right now if you go and see, my Terraform TF state file is having some content here, right? So let's just go and type Terraform init and enter. So it is initializing the backend again. And soon all the data will be disappear from here, and see acquiring the state lock, right? And if you go and see, it is having the state lock here, right? And if you go and see whether we have something in this or not, so tables, go to tables, and if you go and see, we should have one entry here. Yep, where is that? Items, explore table items. See, right now this is also having the same ID 787A87 here, and again just go and see this 787, this one. Okay, right now it is showing this different ID, but it's like they both are logged. See who has logged it. If you just go and see that here, see this is the ID, and see content only has logged it. So now it is prompting me, do you want to migrate your state? So I need to type yes. I'll type yes. Once I'll do that, so all the data which is present here in my local state file will move towards, see everything is blank now. It is successfully migrated my complete Terraform state file to Terraform backend in S3 bucket. So it is now successfully migrated. Now just go and see the S3 bucket which you have created. So here just go and refresh it. See, so my state file is now present here. Okay, you can't see it directly because it's a private. Okay, and if you go and see this, it will also be removed. So if you go and refresh this, the lock will also remove from here. See, you don't have any item right now. See, right now we don't have any log item. We are done with the state file migration also, right? So we have covered till this much of the project. Now let's just go and push the complete code which we have written into the Github repository. Okay, so for Github repository, what we have done. So here, this is the code which I have written for git push, automating the git push. Now there is one local provisioner block I have written. Yeah, see, this is one more option we can do. Instead of writing a provisioner block inside the CloudFront, we can write the null resource also for the running the graph. That's also the same thing it is doing. And here what I have done, I have written one null resource which has to run at last once everything is been done. I want to push all the code into my GitHub repository. So let's just do the same task now. So just go and create one local provisioner.tf like this. Just copy that. Okay. So we have done and we have created local provisioner. Now we need to create a git.sh file which will have all the step which will push complete code from local to remote repository. So just copy that and paste it over here. Now we need to create one repository and we need to pass our SSH key to my GitHub account. Okay, so here let's just go and create one repository named TechSavvy demo code. So this is my repository name. Okay, I want to create this as a public, so create repository. So we have created a repository. Let's just take the SSH URL. So because I want to push the code with the help of SSH URL, not HTTPS URL. So just copy that and paste it over here. Okay, done. Now one more thing before pushing the code, let's just create a git ignore file also, just like here, this one. Okay, so it will help me to not to push this .terraform folder. So just go and create one file .git ignore, and I don't want Terraform folder because it's having very large files available here, and what is the point of pushing those stuff into the GitHub repository, right? So just go what I was doing, yes, here. So this is my GitHub repository, and now I just wanted to provide the authentication. Yeah, and again I need to replace the same URL here also, like that. So what this git.sh is doing, all the step, first it is cloning the repository, and what it is doing, it is syncing that repository with my local repository. See, once it will clone, it will create one folder here, right? So it will sync everything what is present here into the repository which has been created. Now it will go and change the repository and perform the git add, git commit and git push. Okay, so now, but it required authentication. Okay, so what we will do, so go to the WSL and generate the SSH key using SSH key gen command. But before that, let's just go and let me show you whether I have any key available or not in my home directory. So just go and do the ls-la and to my home directory. So see, right now I don't have any .ssh folder available. So let's just go and run the command ssh key gen and enter. So see, it will generate one key here. Okay, so now if I'll do again, see, .ssh folder has been created. So if I'll do ls-la to my home directory ssh folder, see, two key is being generated. One is public key and the other one is the private key and the public key. So let's just go and do the cat. So id cat tilde.ssh id -rsa.pub. Okay, yes. So now this is my public key. So just copy this public key and go to the GitHub repository here, and under this setting option, just go here and update the SSH key here and add the new key. So I'm adding WSL key here. Okay, and just paste it over here and add it. It will prompt you to type the password again, so just type it and confirm. So what you have done, you have added the key. Now we have added the code also, everything is working fine. Now just go and do the Terraform plan. So let's see what response it will give. So see, our code is ready, everything is ready, right? We have a repository created here also. Right now my repository is blank. I want whatever code I have written, it has to move to my repository. So I have written this shell script which will help me to push the code from my local system to GitHub repository. Okay, it is showing that no changes has been done. Maybe yeah, I'm sorry, this is the problem. This code is commented somehow, so just uncommented, because yes, null, if that null provisioner will not work, then how this git will call. So just again run the Terraform plan. Okay, it is saying that as we have introduced one new null resource block, so it is saying just to do the Terraform init once again. So just do it Terraform init, so that it will download this null provisioner. Okay, done. Now just do the Terraform plan again. Okay, so as per the plan, it will execute my null provisioner which I have written here. So now just go and apply the changes. Auto approve. Okay, so the changes has been picked up. So it will call this git.sh file. See, it is prompting me for the fingerprint again. Yes, it was just asking me that are you trusting that device, like you want to add that particular SSH key to known host. That's fine. Like first time it will ask, but next time it will not ask. So see, so in the git.sh you can see that it has first created the repository, like clone the repository. After that it has moved all the data into that repository. Once that data has been moved into that, then it has performed the git add git commit command. See, they have inserted all the 28 files as a commit part. Then the git push command has been performed and we are successfully moved our code into the master branch. If you want to see and verify, so just go to this branch and refresh this page. See, so your code is being moved here 1 minute ago. Okay, and now just go and copy this CloudFront URL and paste it into the browser. You will be able to see the output as expected. As per this architecture, we have successfully completed all the steps. Okay, we have also moved our code into the Github repository. So now as the next part, as we are done with the practical and we have executed, so as a best practice, we should destroy the infrastructure if we are not using it. So here just go and run the command called Terraform Destroy auto approve, and it will destroy everything. See, so all the 28 resources which we have created here, it is now in the destroying state. So it is going to destroy everything. Okay, so the only thing, that state file bucket will not be deleted because it's not empty. So we can't delete it like that because our state file is still present. So that we will delete manually, but rest all the things are being destroyed. So just go to the S3 bucket here and refresh this page. See, only this state file bucket is left out. So just go and delete this first document. You can also automate this part also. So if needed, you can do that. So just go and select it and delete. And just go and verify whether my API gateway is deleted or not. See, deleted, right? DynamoDB, let's see whether it is deleted, because it was also related with the backend. Maybe it was not deleted. So yeah, it is deleted. S3 bucket, we have deleted both of them. Now Lambda function. So this is also deleted. Okay. So with this, we are done with our project which we started creating. Now let's just see some of the best practices. Okay. So as a best practice of Terraform, you should always manage your state file at remote location, and always choose the backend resources or the backend option which has a state locking facility to avoid the conflict. And always try to back up your state file also, and always try to do the backup of your state file also if someone has accidentally changed anything into your infrastructure, so that you will have any older version available with you, so that you can recover your infrastructure from that. Okay. And one of the, like, not exactly the best practice, but it's like a good way and as a good gesture of writing or creating a code is create a code in a generic code, right? Now what is the meaning of generic code? See, the way we have created a code, we have created using a variables. We have not done anything hard coded, right? So anyone can go and change their variable values. See, here anyone can go and change the values in the TF bars, and they can go and customize, and they can use this code the way they want to use it. So this is also the best practice and the coding structure which we should follow. And also we have followed the drive principle. We have not repeated the code. We tried to keep the coding standard. So this is how we can write the code, okay, like a generic code. So these are some of the best practices which I wanted to highlight for you. There are many other best practices also, but as per our code or our project or the POC which we have selected, these are some of the best practices we have followed, and it's always recommended to follow some of the best practices when you create or write any project code in Terraform. Thanks for watching. Please share your valuable comment in the comment section. Also, please subscribe my channel